So here we are, halfway through the course, starting on chapter 1 now. So types of set and set notation. Let's just take a quick look in the book because we're going to be covering this material. But if you want to know where to look in the book to augment the material that's on the worksheets, then here it is. This is the place. And there's some different examples here, right? This one's on categorizing provinces and territories using sets. So just to show you, it's not all numbers, right? It's not all numbers. We can categorize different things into sets, and then all the definitions are down the left-hand side. Anywhere that they're referred to here, if it's in green, then either on the left side or the right side, you'll see a definition of that kind of stuff. Okay, so it's just a place you can come look. And if we sort of keep going forward, then one place you should definitely look is when we get to the end. You've got these key ideas. So at the end of every section, the key ideas. So that's definitely something that you want to be looking at, after we go through stuff. All right, so here we are. Types of sets and set notation. So definition. A set is a collection of distinguishable objects. So distinguishable just means you can tell them apart. So if we talk about the set of whole numbers. So to indicate a set, we use brace brackets, these guys. All right. And if you look on your formula sheet, you'll see that when it says set, so there's a whole bunch of stuff on your formulas that are on your formula sheet. And it's under logical reasoning, so it's in the bottom right of your formula sheet. You'll see stuff like complementary set. So a lot of the things that we're going to define here. But when you see a set of brace brackets, that's a set. An element is an object in a set. So a set of whole numbers, 0, 1, 2, 3, etc. So 3 is an element of the set. Universal set is the set of all elements under consideration for a particular context, also called the sample space. So for example, if we did the set of digits, it would be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Right? So that, what you see on your calculator pad or on your telephone dial pad, right? That's the set of digits, and then it's calculator, we can make any number from that set of digits. Subset, a set whose elements all belong to another set. So for example, the set of odd digits, if we define that O, equals the set consisting of 1, 3, 5, 7, 9. And if you want to write that in set notation, you use this sideways U. So this says that O is a subset of D. Okay, and that one is on your formula sheet. They don't have the brace brackets, but they do have the sideways looking U, and it says subset. Complement. All the elements of the universal set that do not belong to a subset. So for example, O, the subset of digits, D, consisting of 1, 3, 5, 7, 9, that's that set. All the elements that don't belong to it, in other words, 0, 2, 4, 6, 8, that's the complement. So it's everything that isn't a member of this subset. So we have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Here we have 1, 3, 5, 7, 9. The complement is what's left. So if we went up here and kind of crossed off those guys, we could see that we have 0, 2, 4, 6, 8. The subset of the digits, the universal set. Empty set, a set with no elements. So for example, the set of odd numbers divisible by 2 is the empty set. Notation is the brace brackets with nothing in there, or a circle with a slash through it. Okay, and again, that circle with the slash through it is what's going to be used as an empty set on your formula sheet. And the first thing, and so this is under a heading called logical reasoning, because the province sets up relations and functions. That's everything we've done till this point, right? Linears, quadratics, cubics, so polynomial functions, rationals, exponential, logs, and sinusoidal, right? All of that is under the heading of relations and functions. This goes under the heading logical reasoning, and then there's one more heading, which is probability. But the two are tied very closely together. So empty set. Disjoint sets. Two or more sets having no elements in common. For example, if you have the set of odd numbers and the set of even numbers, they have nothing in common. The number of elements in a set, and that's denoted by a little n, lowercase n, and then bracket d, so where d is the name of the set. So it says the number of elements in the set d. So the number of elements in the digits, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, there's 10 elements in that set. An infinite set is a set with an infinite number of elements. So for example, whole numbers, 0, 1, 2, 3, dot, dot, dot. So dot, dot, dot says keep going along that line, 4, 5, 6, 7, and so on. A Venn diagram. So we have D, which is our universal set. So what we do is we put that in a box, right, or a rectangle. We've got O, the set of odd digits. So basically, I want to take 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. I want to place them in this set. And it says label O prime. So what we're going to do is create another circle, call it O prime. And now we're going to put the numbers in where they belong. So 0, so does 0 go in O, O prime, or outside of both circles? Okay, so O prime, the way to read that would be not odd or even, right? But we're calling it not odd. These are the odds, these are the not odd. 1 is odd, that goes in there. 2, not odd. 3, odd. 4, not odd. 5, odd. 6, not odd. 7, odd. 8, not odd. 9. So we've got our O, 1, 3, 5, 7, 9. Those are inside the circle O. Right? They are an element of, each one of those is an element or member of the set O. O prime, also read as not O, O prime is 0, 2, 4, 6, 8. Practice. List the elements in each of the following sets. So prime numbers less than 20. So P is. Okay, so list the elements. Write down each prime number that is less than 20. So give you a moment. Ask a question. Is 1 a prime number? No. So by definition, 1 is not prime. Okay? 1 is not a prime number. So then we're going to start with 2. Are there any other even prime numbers besides 2? And the answer is no, right? Because the definition of a prime number is it's divisible only by itself and 1. So 2 goes into every even number. So every even number gets taken out by the 2. So 2 is the only even prime number. We've got 3, so 4, no. 5, 6, no. Forget the even. 7, 9. 9 is divisible by 3, so we're not going to have 9. 11, what's next? 13, and then? Now we're just going less than 20. So 19. Yeah, the next prime number would be 23, right? But we want less than 20. So these next 3 units is going to be a lot of interpretation of, okay, what do they mean, less than 20? So less than 20 means you're going to max out at 19, right? It's not less than or equal to 20. In this case, 20 wouldn't matter either way. But if they had said less than 23, we would not be listing 23. If they said less than or equal to 23, then we would include it. So this unit and these next 3 units are going to require a lot of interpretation when you're reading a scenario to decide what's included in this set, what isn't. Okay, I need to sit down and think about it a little bit before I rush an answer. Sometimes you slow down to speed up. So you slow down and say, okay, hang on, let me just list these. What's the criteria at the end? Do I include this number or not? Here's a set T, which consists of little t, such that t is equal to 4 times x. Now, at that point, it's legitimate to ask, tell me about x. X is between 1 and 4. And x is a natural number. So what value, so the first value that x would take is 1. And t, capital T, consists of the set of little t, and little t is defined as 4 times x. So the first number, x, we can use as 1. 4 times 1 is 4. What would the next number be in capital T? What would the next value of x be? X is 1, and then it's going to be 2, right? So it's x's natural numbers, right? So natural numbers are the counting numbers, right? How many people are in this room? 1, 2, 3, 4, 5. The counting numbers, right? Whole numbers include 0. So, lunchtime, nobody's in the room. There's 0. And people start coming in. Okay, if x is 2, what's 4 times 2? Would be 8. What's the next value for x? 3. So the next number in capital T is? What's the next value for x? Do we include the 4? Yeah, because it says less than or equal to 4. So we need to be paying attention to these signs. What if it said 1 is less than x is less than 4? Then we would only be using 2 and 3. Right? We wouldn't include 1 if there's no less than or equal to. Right? If 1 is less than x, then x has to be bigger than 1, strictly bigger, not equal to. So this definition gives us a way to fill it. Now, I mean, are you going to do that if the set is just 4, 8, 12, 16? Probably you would just write down t is equal to 4, 8, 12, 16. But maybe we say something like x is between 1 and 100. Okay, and if we did that, let's do that here. We'll just add this in. Let's make another set. Let's call it s, little s. S is equal to 4x. 1 is less than or equal to x is less than or equal to 100. And x is a natural number. So if we wanted to show that set, we say, okay, we just started out that way, right? So we know we're going to get 4, x will be 1, then 8, then 12. Where's it going to end? 400. And that's another way to write a set. So that set is not infinite, but it's got a lot of elements in it, but we don't want to list them all. We're not going to go 4, 8, 12, 16, 20, 24, 28, 32, 392, 396, 400. We just list it and say, basically, look, we're doing any multiple of 4 that's less than or equal to 400. Tony's the owner of a sandwich shop. Thought I went through this, looking for mistakes. Wish I went through this. I don't know how that. Customers may put any of the following topping on their sandwiches. I've got it right second time. Lettuce, tomatoes, cheese, pickles, onions, olives, roast beef, and salami. So let capital T equal the set of toppings available at Tony's shop. State the value of n of t. So what is n of t? And then say what it means. Nobody said what it is, and nobody knows what it means. What's n of t? So look above, defined for you, somewhere above. No, what's n of t? I think it's 8. What does n of t mean? Okay, you can say it. It's the number of. So n bracket t brackets is the number of elements in the set, capital T. The number of elements in T. Right? If you wanted to enumerate T, then you would say T equals the set consisting of, let us, et cetera, et cetera. N of T is how many things are there, how many toppings are available. Okay, there's 8 of them. So that's what N of T means. Now, on your formula sheet above logical reasoning, you have all these formulas for probability with capital P. Anywhere you see a capital P, you can use a lowercase m. So they don't give those formulas, but if it's a capital P, then we're talking probability. It's the probability of something, right? That's 2 units from that. So don't worry about that. That's the last unit. But for now, just recognize, hey, if I'm looking at the formula sheet, wherever I see a capital P, I can use a lowercase n, and it means the number of, like how many. So, state whether each of the following is a subset of T. Is olives, pickles, tomatoes a subset of T? Yes or no? Yes. Why is it a subset? Yes, they are all elements of T. They are all. Just remember, an element is one of the members of the set. They are all elements of T. Lettuce, cheese, bacon, salami. No, why not? Why not? Well, which one is it? Bacon. How did they leave out bacon? No, for some reason. For some unknown reason. Bacon is not one of the available toppings. You don't need to write for some unknown reason. You can't. The subordinate clause modifying. Why would you leave out bacon? The empty set. Is the empty set a subset of T? You're nodding head. You're right. So the empty set, by definition, the empty set is a subset of every set. Okay, so yeah, yes. By definition. The empty set is a subset of every set. Is T a subset of T? And again, by definition, yes. So a set is a subset of itself. Ooh, the shelves are here. So T, yeah, so every set is a subset of itself. Every set is a subset. So all the elements in T are a subset of T. They just happen to be the entire set. But those are definition type stuff, right? Like the empty set, that's a subset of every set. And all the elements in a set are considered a subset. So every set is a subset of itself. Right, and again, just basically, yeah. We'll try something. Draw a Venn diagram to show. So a Venn diagram is a circle diagram, like the one we did up here. This is a Venn diagram. So it's got a box. Inside the box are all the elements, the universal set, every member of that set, whatever we're defining the set to be. And then maybe we set aside some elements. We have a subset. So 1, 3, 5, 7, 9. So every set will be a subset of the universal set. Okay, whether it's empty or it has elements, every set is a subset of the universal set. Okay, there's no camera here. Draw a Venn diagram. So we're going to show the universal set, which is natural numbers from 1 to 20. So what are those numbers? Start it out. 1, 2, 3, 4, 5, 6, 7, 8, 18, 19, 20. Inside here, we want to have, in set A, multiples of 4. So you know what? Why don't we go list these? So just make a list. So before we go and jump into the diagram and start throwing numbers down inside the box, we should know what should be in what circle. Okay, so do your multiples of 4. Do your multiples of 5. And then do your multiples of 10. Because we're going to want to ask ourselves, does a number, now remember, every number from 1 to 20, we read 1, 2, 3, 4, 5, 6, 7, can only be written once. So then, should there be any overlap between these sets? Is there a number that belongs to more than one set? Well, we can say, look, 20 is going to be in all 3 sets. So we better draw 3 overlapping circles. So let's start with 20, because it belongs to all 3 sets. Is there any other number that is in all 3 sets? We would say, okay, 20, then I've got a couple of 10s. No. So where on this diagram are we going to put the 20? Right in the middle. Okay, so here's the question asked. Is 20 inside the circle labeled A? Is 20 inside the circle labeled B? Is 20 inside the circle labeled C? Okay, good. We've done our job there. Where does the number 1 go? Inside A, inside B, inside C, none of the above. So we'll just put the number 1. Okay, so see if you can fill in the rest of that diagram. So you want to put in 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, and 19. You can only write each number once. And after you've written the number, ask yourself, should it be in A? If it is it in A? Should it be in A and B? Does it belong to both A and B? Does it belong to both A and C? So right now, here we got 20. 20 belongs to A and B and C. Well, 2, 3, those are easy. Where does 4 go? A. Like, here A, here A, here A. Yeah. So where the 4 is, we're going to call that's only A, right? It's only in A, not in B or C. Where does the 5 go? Well, only B, right? No overlap. What would we call this area here? A and B, right? It's in both A and B. Are there any numbers that are in both A and B? No. Okay. So we can start plunking down the rest of our numbers now. 6, 7, 8, only A. 9, 10, where does 10 go? So is 10 inside circle B? Is 10 inside the circle C? Is 10 inside the circle A? No, that's good then, right? It's right where it belongs. It's inside B, it's inside C, so it's in both B and C, but not A. Any odd numbers outside? I'm just going to fill in the rest of the odd. Oh, not all the odd numbers. So 15. 15 will go in just B. Right? We got the 10. So we've done with all the numbers. Oh no, we got 12 and 16. So 12 and 16. Okay, and C's got all of its guys, right? It's got the 10 and the 20. All that's inside C is 10 and 20, and here's C, and there's inside C. So we got the 10 and the 20. Inside B, we have 5, 10, 15, 20. Okay, so check, check. Inside A, 4, 8, 12, 16, and 20. Check. All right, let's just put down the rest of the numbers. So 13, 15, no, 16, no, 17, 18, 19, and 20.
14?
14. Where's 14 go?
Goes in between 11. Goes 13.
Yeah. 11. 13, 14, 17. That was the final check. So the final check was look back. You know the 4-step problem solving method? George Collier is a Hungarian mathematician, but it doesn't apply just to math. It applies to anything. So the 4-step problem solving method is step 1, understand. What information am I given and what do I have to do with it? Right? You could be writing a social studies essay. What information do I have? What do I need to do with it? You could be a lawyer writing a contract. What information do I have? What do I have to do with it? You could be a doctor going into an operation. What do I know about the patient? What am I doing? Right? So it's collecting information. Understand. What's going on? What am I trying to do? Bless you. The next step is plan. Okay, what's my plan? So if you're a lawyer writing a contract, okay, I've got all the information. You're going to sit down and draft it all the time. If you're the doctor, you're going to plan out the operation. I'm going to go and mark on which leg it is I'm going to cut off. Don't want to cut off the wrong leg, right? So put a big X on it, or whatever it is you're doing, right? You want to plan out. I want to know what I'm doing before I walk in there. I want to make sure I'm going to be doing the correct thing. And in math, it's like, okay, I'm going to use some formulas, and I'm going to substitute into the formula. Step 3 is do it. Okay, so sit down and draft that contract, write the social studies essay, write the English essay, put the numbers inside the box, inside the correct circles. And the last step is look back. So if you're the lawyer drafting the contract, you want to look through the whole thing. Did I misspell sandwich somewhere in there? And obviously, I don't look back very well. If it's an English essay, okay, I know what I was supposed to write about. Is that what I ended up writing about, or did I get off track? And, you ever get comments back on an essay saying you're off track? Right, you're rambling now, like your math teacher is every day in class. So look back. Here, the look back would be, do I have every number from 1 to 20? Is it inside the circle that it's supposed to be? Right, did I leave anything out, like the 14, which I left out on purpose? Wasn't on purpose. Forgot it. Started doing odds. Disjoint sets. Are there any sets that do not have any common elements? So is there a set that I could have just split off by itself? And no, right? Because A has elements that are inside A, but also inside B and also C. So the 20 in the middle to A and B and C says there's no disjoint sets, right? That element belongs to all 3. Is each statement true or false? Explain. Is A subset of B? So is every element that's in A also in B? No. No. The elements for 8, 12, and 16 are only in A. Is C a subset of A? Okay, why not? You're going to say no, but why? Yep.
Because of 10.
Yeah, 10. So the element 10 is not in A. So C is a subset of A, says everything in C has to be a member of A. Is C a subset of B? Yeah. Okay. So everything, yes. everything that is inside C is also inside B. Every element in C is also in B. They're basically multiples of 10, right? Every multiple of 10 is a multiple of 5. Right? 5, 10, 15, 20, 25, 30, 35, 40. Every multiple of 10 is an element, is a multiple of 5. Right? So we could say every multiple of 10, every multiple of 10 is also a multiple of 5. So set C is multiples of 10, set B is multiples of 5, so every element of C is somewhere inside B. C prime. So C prime is all numbers from 1 to 20 except 10 and 20. So C prime, is that true? Is C prime all the numbers, 1, 2, 3, 4, 5, 6, 7, 8, 9, 11, 12, 13, 14, 15, 16, 17, 18, 19, are those, is that true? So are 1, 2, 3, 4, 5, 6, 7, 8, 9, 11, 13, are they all outside the circle C? Yes. So it's true. True, because C only has 10 and 20. C consists only of 10 and 20. So C prime is every number that is not 10 or 20. Is C a subset of C? Yeah, so by definition, a set is a subset of itself. Draw a Venn diagram to show universal set. So U, the universal set, is a deck of 52 cards. Standard deck. Is everybody familiar with the deck of cards? Okay. If not, if you look in your textbook, somewhere in there, somewhere in chapter 1, you'll see a diagram with the deck of cards. Okay, and it'll show you all of the cards. So for now, just to review what's in a deck of cards. So there are 52 cards in a deck. How many weeks in a year? 52. Coincidence? I think not. There you go. Maybe it is. So there are 52 cards. So we do not include jokers. Those are familiar with the deck cards. We're just talking the standard deck of 52 cards. It consists of red cards and black cards. Okay, so half the cards are red. They have hearts and diamonds. Half the cards are black. They are spades and clubs. There are 4 suits. Okay, so hearts, red, diamonds, also red, clubs, black, and spades, black. Each suit consists of 13 ranks. So the ranks are the actual cards themselves. Okay, again, if you're not that familiar with the deck of cards, you'll find the deck of cards in, there'll be a picture in the book somewhere in chapter 1, just kind of flip around. So the 13 ranks are an ace, which has an A on it, 2, 3, 4, 5, 6, 7, 8, 9, 10. Those are the numbered cards. And each of them has a number of, if it's hearts, then 2 of hearts has 2 hearts on it. The 3 of hearts shows 3, the 4 of hearts shows 4, and so on, up to the 10. And then there's a jack, a queen, and a king. Those are called the face cards. They have faces. Okay, they're denoted by a J, a Q, and a K. Now, we're not dealing with any of that. Today we're going to look at red cards, we're going to look at hearts, we're going to look at diamonds. Okay, so red cards are going to be all of the hearts and diamonds. Hearts are hearts, diamonds are diamonds. Are there any hearts which are also diamonds? Was there any card which is both a heart and a diamond? No. No. I know, right? That's laughable. So we don't need to put any overlap, right? So there's overlap, right? Like 10 and 20 were a member of set A, set B, and set C. There was overlap. An element belonged to more than one set. Okay. Now, if I do those, I can enclose them in an R, right? Because they are red cards. And then I can have another circle, oval, for the black cards. Are there any red cards which are also black? Obviously no, right? A card is either red or black, not both. So in this next few sets, could use some sets. In these next few sets of chapters that we're doing, right? There's a lot of interpretation of the language. A lot of times we ask, is it just a member of set A? Does it belong to A and B? Does it belong to A and B and C? Maybe just A and B? Maybe none of the three? Right? And we have to decide, as we're looking at these things, where does this thing belong? How do we categorize it? Okay, so we've got the red cards. Inside the red cards, are either a heart or a diamond. Is there anything inside the R circle, just the R circle, but not inside H or D? Right? No, because if you're red, you're either a heart or a diamond. Are R and H disjoint sets? Are they totally separate? No. Are H and D disjoint sets? Yes, right? Because you can't belong to both. True or false? D is a subset of R. Yeah, so if the D circle is inside the R circle, then it's a subset. True or false? The number of red cards is 26. True. True or false? The number of cards that are hearts or diamonds is equal to the number of hearts plus the number of diamonds. Let's back up. How many hearts are there? 13. How many diamonds are there? 13. How many spades are there? 13. How many clubs are there? 13. How many heart or diamond? If you're a heart or a diamond, how many choices? So is 26 equal to 13 plus 13? Yes. So that's true. Stuff like that will not always be true. Okay, but we'll see that in the days to come. And this day has come, as far as this lesson goes, to an end.